Okay, so before the break, we were looking at reading and writing files. Just had some simple examples. There's a problem. Somebody called along had a problem. We tracked down the thing. And well, from our little example piece of software, we took that data and wrote that to a file. And most of the software, you're right, you're going to want to do that. For those developing maybe a game for your final project, you're going to want to take at certain points along the way, store the variables like the position of your character and how much health they have, and just stick those numbers in a file so that you can save the game along the way. Or those doing like a some sort of sales thing. I think a couple people jumped on a restaurant when that one shows up a lot, because a lot of people working their way through college in restaurants. So it's fresh on everybody's minds, or some people's minds. So whenever you place an order, you're going to want to write that order to a file so that you can, in a larger situation after class, so that you can pass that file on to the kitchen and they make the order. And then later you can print out the bill based off that file, but you're going to want to save it. So just take those data points and write them to a file, and pay attention to the order you write them in. We call them sequential text files. And just make sure you read them back in the same order you wrote them to the file. And then you don't have to actually worry about handling that yourself. It's a useful thing, but then that distinction that I was making earlier, that's only the data in the file. Our file handler is only looking at that data, those particular numbers, but there's other stuff with that file. If I show the screen and look at that one we just looked at before class, or before the break, there's other stuff about this file. It was created, or it was last modified at 2:04 on today's date. It's a text file. If I right click and go to properties, there's even more information: how big it is, how big it actually is, how much space it's taking, when it was created, when it was last accessed. I guess there was a question earlier about security things, and that's going to be unique to the situation, but that last access one is probably a important one for that. But there's all this other information that is not included in the data in the file. If I open it, our file handler only sees the data. So that's that little distinction, because a lot of y'all are heading down a pathway where you're going to want to do stuff with the files, not just the data in the file. And well, that's kind of what we were looking at the other day, the operating system control languages. We looked at PowerShell, but the old command prompt in Windows still works. The Unix commands in a Bash shell or Z shell, or there's lots of different options. There's also some less common options that have really nice features, or we're programmers. We tell the machine what to do. And we can build our own thing to take text from the keyboard and pass it on to the operating system. But that's the thing. The operating system is what knows the files, and the file handler that we work with in the program to save our data, that's only the data. So we might want to work with the files, and we can do that in Python. And that's why when we started today, I mentioned something about that. Is there not an alls list? Oh, well, on Windows 10, I was going to scroll down and look for things, but I don't see the list I was looking for. But wherever idle's installed, you can open this up. We can also do that stuff from Python. So for this one, oh, there's only one thing open. I'm going to do, why did I do that? Half the screen. Half the screen. There we go. It was determined to put 4 things on the screen. It's things that we would normally do in the shell, sort of the live time environment, like we would do in PowerShell or a terminal. But I'm going to type them up in a text file and then copy and paste them over so I can share that file with you. So that other stuff, we need to actually have our operating system do. So we'll go, so we have to bring in some libraries. They're included in the default installation of Python. And I asked you to install it because if you're like at the little IDE in the textbook or using a cloud-based one, and you try to access the operating system file structure, you're going to get the file structure on that server it's running from. But at least for our example, it's probably better to use the local one because the file structure on that server that the online stuff is running from, you probably don't have access to those files. So it wouldn't really be, it wouldn't even let you try in a lot of situations. Like the files that Cengage, the other stuff on that server would be like the files used to grade it. So you definitely don't have access to those. So this is things that need done on a machine you have access to. And it's included with Python, but it's not, Python is huge. I mean, we don't want to load everything available in Python at once. So by default, the stuff we've worked with this semester is those basic tools that I think we're going to need every time. But there's also lots and lots and lots of pre-made code included that we have to ask for explicitly. We have to bring in libraries, and our keyword for that is going to be import. So we need to import the OS library for this stuff. OS for operating system, because the operating system has the files, and most of y'all are heading down pathways where you want a little bit more than just the data in the file. Well, actually, everybody will eventually, because even software developers are going to need some of this stuff. We saw earlier when we just say write a file, it puts it there in the same directory, but a lot of times the directory our program is running from is not where we want to write the file. There's another one here. There's 2 of them. So OS, well, actually, I'll look at this and point at what these are. So we want to import OS and os.path. And I'll talk a little bit about these to let you kind of see what's going on. So if I go to where Python's installed on the C drive under users, there's this account. You have to turn on hidden folders to see it. But one of the things under the user accounts will be app data. And then there's a file called local. And then that has a folder called programs. And then that has the Python language. And in there, there's, so here's the interpreter. And all the stuff it knows about is this file lib. So when we say import, the keyword import goes over here and looks at these through these folders and other Python scripts. Are these in alphabetical order? Yep. So here's that one I just said to import, the OS. So if I open that with idle or Adam, that way I don't have a run button next to it. So we need this other pre-built code. And in there's a lot of things. So a bunch of pre-made functions and other code that will run. Some of this might look like a mess. Maybe not the best example. Right? You'll know what the keyword if means, and then indent things afterwards. But a whole bunch of pre-made code for us to run. So we need to bring that in. And then there's some other stuff in that file that we can access, and one of them being this path object. So to work with the files themselves, we'll need both of these things. And then it's kind of the stuff we would do in PowerShell or command prompt lots. If I quickly open that from the other day, just for the classic example, when we have these command terminals, our operating system control language, we're usually doing things like changing the directory we're working in. Go over to documents, delete folder. Oops, got to spell it right. Change directory to documents, delete, spelled correctly, and then we can list out all the stuff in that directory, see the files. So that's working with files. So most of y'all are heading down a pathway where you'll need to do that in any scripting that you put together. And since we're looking at Python, might as well throw this in here. At several curriculum committees, there's been debates going on for a while about trying to work more of this stuff in, and because some people, that's all they need the coding stuff for. That's why I wanted to go ahead and include it. But these two libraries, if we import these, will give us access to run those traditional command prompt sort of instructions from a Python script. So say import OS and import os.path. We have both of those on call directory OS. So here's all the stuff we can call from that OS. We're not going to look at everything, but a bunch of different options there. I don't know why I'm keeping that open. Where's one we're going to look at here? Change. There we go. So like change directory, that was something I just put in CD. There's an instruction in that OS library called chdir for change directory that would do the same thing. I'm not going to do this split screen thing. I thought that might be a good idea, but maybe not. I'll just, that way we can close the shell and kind of rerun it. Also, if I run this now, if I save it and then run it, and then try to ask for that OS stuff again, it does know what it knows what it is. So we can access that stuff directly from calling OS as well. And again, there's no clear button, so I'm just going to close that. Y'all go ahead and run that. And then to work with our file structures the same way we're doing, only in text, right? You're probably used to opening File Explorer, or for Mac people, opening Finder, and then go into the documents folder, the delete folder, and look at the files in there and do stuff with them. So we can do essentially the same thing here. So if we say os.get cwd, that's our current working directory, which actually I should do that from over here so I can send you this file. So that operating system library, and then a dot for one of the things in that library is get cwd for current working directory, which is a function. A little bit of predictive text there. Return a Unicode string. So this is sort of something I mentioned the other day. The old style command prompts written back in the 70s, all they give us text back. So when we do it in Python, that's what we're getting as well. We're getting text back, but then we can use that text in a script. So I'll grab that, and if I hold shift and push home, it'll highlight the whole line. So copy that, paste that in here, and kind of says where we're working at. We can change that directory as well. So like os dot change dir. I'll do dot dot. If you haven't seen it before, dot refers to the current folder you're in whenever you're working with folders. So if you say you want to go to the directory dot dot, that means go up a level. So we're going up to the parent folder that we're in. And if I call os.get current working directory, or CWD again, you see we went up a level. Or os.change directory all the way back to the beginning, C:users. I'll go to into the user account. And notice I use the regular / even though I'm on a Windows machine, which should be using backslashes for directories. If I do os.get CWD, the current spot we're working, Python automatically changed it appropriately for the system. We could use either one, but this is the more general one that it will correct for the system. It will adjust it to the system you're working on. So that's the basic changing around directory, navigating to different places. Like I always work in my delete folder. So I can say os.change directory to C drive, the users folder, the Frank directory, and yeah, the predictive text in idle is really slow. From there, I have a documents folder and a delete folder, and that's where I always work at. You all have seen that before, and then just copy things over to a more permanent place. That way, to keep the computer stays nice and organized, and whenever there's a bunch of things that need deleted, I know where they're all in the same place. os.get current working directory. So those are two that are going to be used quite a bit. So I'll just copy that over to this example that I'm going to send you. Whoops. Change directory and get current directory. Which I should probably do this. Current directory is that os.get CWD. And then we can print from there. It's a better idea to save it somewhere first. Copy that and then come over here. I'll add some print statements on because if we're in a saved script, it won't just automatically jump over there like that. Another one that's really useful. Do I have to open the idle shell again? I guess I should have just kept it open. Import os.change directory to that working spot. Well, get current working directory, probably do this first, see where we're at. Oh, that's not where I want to work at. os.change directory. Oh, did something pop in the chat room? Oh, no, guess not. To C users, that user documents, and the delete folder. Then check, make sure we're in the right spot again. And we might want to know what's in that directory. It's probably the main reason to go there, right? So os.list dir will give us everything in that directory as an array, which we probably want to save somewhere. So I'll just call it stuff is os.list dir. And then, well, once again, we could just print out stuff, or we could loop through it and see what's going on. Let me copy this over. Get the files and folders here as an array. I'll put quote marks around it as an array, because, well, we talked about the difference between an array and a list the other day. That subtle distinction, but array is what we usually say. And then once we have it, we can sort of do stuff with it. Yeah, I'll run this. That's probably a better way to get back to where we just were and clear that thing out. Okay, so we go over to that directory, make sure we're in the right spot. We have all of that stuff retrieved, so might be good to do some stuff with that. And for that, we can use the OS path module. So instead of just printing this out, what you're more likely to do is sort of loop through there and work with the stuff in there. Like maybe you want to know which things are folders and which things are files. So I'll set up a couple arrays to split them up. So an array of files, an array of folders, and then just use another one of those for each loops. So for each item in that stuff array that was created right up here, we can just split it up using a selection structure. So if, and here's where we need that other one, this os.path, the dot path there should sound a lot like file path, the thing we're actually working with. So it has things we can check. If os.path, such as is dir, will tell us whether the thing we're looking at is a directory or not. So is the current item a directory? If it is, then we'll add it to the folders. Append item. Well, everything we have is either a folder or a file, right? So if it's not a folder, then it has to be a file. So we'll add it to our other list there. Then I'll print that out. Print the folders are, then print folders. Then I'll just print a blank line, then print the files are, and print files. And then I'll just print a couple empty lines to have some white space. So notice how we're not working with, none of this is about the data in the file, which that's what we actually look at in this class, but most of y'all are on paths where you'll need to know things about the file themselves. So we can grab everything in a folder or a directory as a list. Then we can do our normal looping things and selection structures and the normal scripting stuff we have with the things in that list to kind of see what they are. For us here, we're just looking at the tool and kind of getting an idea about this. So you can see the folders are, looks like there's 3 of them. titles blocking all of my taskbar stuff. I don't like that new thing they put in Windows where software can block the taskbar at the bottom. It's like, I need access to that. It should always be in front of other things. So we have these 3 folders and then a bunch of files. So it's kind of equivalent to going over to the File Explorer and looking through that, only we're having the script do that. So putting basically the idea of putting a script together to work with those files. And notice it's the entire file. All we have at this point is the name. But once we have a name, we could open it, right? Like we just saw, employee handler is open. I'll copy it. This for reading, and for line in employee handler print line. So once we look at the file, we already saw how to have the script read it. This is the next step, like navigating through all our folders and figuring out what's a folder, what's a file. I had a comment in here. It went in the else section, but there is also an os.path.is file if we want to check that as well. But it's an either or, so we could check either one. We don't necessarily need to check both of them, but depending on the situation, you might want to use a different one. It gives us a way to look around the computer from the script and see what's going on. Change the directory, create different other directories. What else do they have in here? Oh, we might need to make a new one. So let me get this stuff out of the way. Oh, save that. So there's all that other stuff, but maybe it's like, okay, well, the folder I was looking for is not here, so need to make one. So os.mkdir, which those who have done much stuff with this will recognize that for making a folder, but there is a better way we'll get to in a second. I'll call it single folder. And I guess the best way to see it is come over here. So you can see we created a single folder. But if I compare that to, say, this Unity project, we go in here, there's usually lots of folders, right? We need to organize things. We need more than one folder to organize things. So along with that, we also have os. Is it make dirs spelled out? Yeah. So make dirs, where we spell out the word make fully and then an S because it's plural. And then we can put in several folders. So like class example, nested folder, more stuff, things. That's probably good. And when we run that, if I come over here, you'll see that created a whole bunch of all those folders all together. And then once we get down to the folder we want, obviously a better way to do that would have been grab this. Path equals that. And then we could do something like, let me delete that first. This would be a better way to do that example. So delete that. So we're going to recreate it, but then os.make there's for that path. So it'll create all those folders again. And then when we get all the way to the end, then we can do something like create a file handler. I'll call it toFile. Open up a handler that's going to go with path plus, I don't know, test123.text. We'll open or create, if it doesn't exist, a file like we saw beforehand. Do all that. Then toFile.write hello world, our standard example to check configurations. And notice there was a return. When we put that in our script, we didn't see the return come back, but it does tell us how many characters we successfully wrote to the file. So if it sends back a -1, then that means it wasn't able, if there's an error, because we could write 0, we could say write and then forget to pass in a string. So 0 is valid, but a negative number would mean an error occurred. So we could put that writing in a selection structure to watch out for negative numbers coming back. We don't really need to worry about that in this class, just letting you know that's there. Then we need to close that, toFile.close. And that's more of the full path on how we would work with, how we would set up our data. Yeah, I'll copy that over. I'm gonna get rid of that one where I typed it explicitly. We set up the path, that way we can keep working with it. Right? We probably don't want to type the string every single time, so it's a much better idea to store that in variables. Then work with the variables, then we can just add a file at the end. We don't need to see the return here. So along with creating those folders, go all the way in here, and then there's where we stored that data. Oh, didn't quite go far enough. We need one more slash there, actually. So let me get rid of that. Go up here. Delete that. So now when it runs, it should create that folder or create that whole long list of folders. Then we'll go one layer deeper in that last folder and create a file. Yes, save to do that. Uh-oh. Oh, and when you go to make a file, make sure that it doesn't already exist. Because, well, you can see there, that causes a big problem. It can't recreate a file. We can check, that's a good place to check for it. If os.path.isdir. So if there is a folder called single folder, then do that. So I guess we need a not there. If there's not a folder named that, then create it. So we'll do a lot of the selection structures and things as we work through this. Obviously, this isn't a requirement. This is something that a lot of y'all will be doing in the long run. So we didn't get an error that time. That folder, it didn't exist, so it created it. Same thing with these. We go in here, get all the way to the bottom, and then there's where that actual data is stored, or the words hello world in this case. But so You can see it's sort of a continuation on what we were looking at with writing files, but we need to do some stuff with the operating system as well. We'll probably want to do the same check. I'm going to delete it here and run that script again. So now sort of duplicating the error we just saw. That single folder does exist, but we're checking to make sure it doesn't exist before we tell the computer to make it, so we can avoid that error message. I don't know why my windows don't do that. So we didn't get any errors because the file already exists. So you'll be doing a lot more things like that, checking about the files. Oh, 3:21. So I'm going to wrap this up in about 5 minutes. I guess we can look at deleting things too. I'll go ahead and do that down here. So instead of, along with making them, we can also delete things. So there's for that path that still exists because it was in our script. So when we ran it, the interpreter here, or our access to the interpreter, does still know about it. So we could remove that. So os.remove spelled out for a file. So like path plus slash, I already forgot the name of that file. Oh, test123.txt. Test123.txt. So doing that, when we go through all these folders, we'll delete the folder or delete the file. If we want to delete a folder, we have a different instruction. And that's going to be os.rmdir. Remove directory, which should look familiar to Linux users that's used the Linux command for a couple of things, but not enough things to translate over. There's only like 4 or 5 things they use the Linux command for. What was the name of the folder? The single folder. We'll delete that one. And notice we didn't get any confirmation. It's more if I go in here. Let me delete those. Yes. I'll run this. I'll copy those so we don't completely lose them. I don't want those to run yet, though. There is a thing we do have to be a little more careful with than just clicking around with our mouse. Oh, I'll delete that here. And then clear out the recycle bin so there's nothing there. Again, there should be a check to make sure that folder didn't exist. We have the same thing. And then those last 2 lines where we delete that folder, just to show it's there. So there's the single folder, and then in here, there's that file. Whoops. Not where I meant to go. So now if we delete that file, we can see it's gone. Just delete it immediately. No surprises there. Same thing if we do the remove directory for single folder. we can see it's gone. But unlike what you're probably used to, where we get that second chance to recover it if we didn't mean to delete it, it is a permanent delete. As soon as that line of code runs, it's gone and there's no getting back to it. So you do have to be careful about things like that. Maybe work in an error message. If you're going in a script, pop up a message that says, "Are you sure you want to delete it?" Something like that, so you don't accidentally go too far with that. What else did I have in here? Move directory, make directories, list directories, change directories. So that's kind of the starting point on those. I'm going to leave the delete stuff commented out here. A couple other useful ones. This is an os.path. We also have one called get size, and then we could pass in the name of a file, one that hasn't been deleted yet. So like up here from our list, drawing.svg. Grab the size of it, make sure it's the size it's supposed to be. So on like a security issue, to circle back to that question from earlier, check the files and make sure they're the size they're supposed to be. Right. This is an SVG drawing, so that means a few kilobytes. 20 kilobytes seems reasonable, but if we check that and saw that it was 30 megabytes on an SVG drawing, that's like a red flag. Something's wrong with that file. That file's not what it appears to be. So we can get the size. mtime os.path.get mtime tells us when it was created. I'll just look at that same one. So there's the time it was created. That looks a little strange. I was going to try to get dates today, get to the dates, but it looks like it'll be next Monday before we explain what that number means. But there's the time when that was created. I'd have to kind of check.
Like the time import.
I was going to go with the actual dates, just general dates in computers, Unix epoch.
Okay.
I guess I can say it really quick. We'll talk about it in detail next week. I was hoping it was on the list for today, but we ran out of. I wanted to end about 3:30. Make sure there's plenty of time to play around with this stuff and get some hands-on learning time. This is how many milliseconds have passed since 1970. Midnight on January 1st, 1970. But we'll talk about, that's how computers measure time. We'll talk about that on Monday because we've already
I have questions about that. That's cool.
We've been over a lot of stuff, but that's how computers tell time, is they just picked a time and said, okay, from here on, we'll just count milliseconds until we run out of until we get too big of a number to keep going. We also have os.path.get C time, and that's change time. So the time it was made and the time it was changed, which I think these are probably about the same. Or did I get that backwards? C time, C time is creation and M time is modified. So I said that backwards. Looks like I didn't save this until like a split second before I closed it. Python gives us the Unix epoch in seconds. So about half a second after I saved it, I modified it by closing it. But those are things that security people would need to know, right? When was the file created? When was it modified? When was it changed? And that sort of stuff is working with the operating system. That's something a lot of the pathways you all are on are going to require things like that from Python. So we might as well look at it while we're looking at Python. Modified time and creation time. And we'll talk about what those numbers that gives means and see how to turn those into a human date. That was something I did yesterday. So we need to turn that into what, May 3rd, 2022. It was during my office hours, so probably about 12:45 in the afternoon. But it doesn't look like it when we see the big long string of numbers. We'll talk about that soon. Kind of quite a bit of stuff there. That's probably enough to get started with, but that's that distinction that I started with. When we write files, read and write files, that's our actual requirement. Oh, let me add this to the chat room, and then I'll wrap things up. Go chat. Is this save? Save and add. What do I call that? File system example. Like that. So there's those things. So you have that to reference. It feeds into that distinction, and a lot of us will need to work with that distinction sometimes. For this class, we just need the data in the file. But that's a little different than the file itself. So when we're working with the data in the file, we're actually working with a handler, which a lot of textbooks will just use that interchangeably with the file, but there is a difference. If we have to work with the file and have like the metadata around it, when it was created, when it was last modified, how big is it, who has access to it, all of that stuff, we have to get that from the operating system. So that distinction does matter, and most of y'all are heading down a pathway where you will need to be aware of that distinction. So that kind of gets us there, and hopefully a preview of how you will actually be using Python in your working careers. And obviously for software developers, whenever your program needs to save a file, you probably don't want to save it in the same spot where that program is installed on a user's machine. So you need to be able to get to those other directories as well. So hopefully that'll be a useful step. This is an active subject, though. We learn by doing, not by watching me do it. So as always, it gives us about an hour and 20 minutes left on our scheduled time. I will be sitting here in case anybody has any questions in that time. As always, text messages and IB Learn messages are the two things that make noise on my phone. And I can jump back on a Zoom call in a split second. If you have any questions, please use our time productively and practice some of these things, writing files, some of that other stuff I showed there that was a step beyond what the textbook covers and our core objectives for this class cover, and into the things that you will actually use Python for, especially cybersecurity and server admin people. That's how you'll use Python for controlling things in your operating system. It's a good thing to practice on, but there's final projects coming up and probably other homework to do. So please use our time productively. I'll be sitting here to address any questions. I can't answer questions for more than this class. There are a number of classes I teach. So use our time productively, decide what would be most productive for you. And if you have any questions, let me know. Does anybody have any questions before we stop the recording though?
None here. That was a great example. Thank you.
Okay, so I assume silence means no questions. So that'll be about it for today. If you have any, let me know. Otherwise, I will see you all on Monday. And yeah, the next thing on the to-do list is dates. So we'll make sense of those numbers. As humans, we don't track time as milliseconds since 1970. So we need to get that into a human readable form. So I will see you all on Monday. Have a good one.
Later. Bye, everyone.
Bye, everyone.